do that. So that way, if anyone wants to go back and look at something, they'll be able to do it. All right, so back to this. So every time we go up a chapter, we kind of ramp it up a notch. In other words, we learn something new, but we keep doing all the same things that we learned in chapter one, which is basically adding, subtracting, multiplying, and dividing kind of things. And then we keep using those same core skills with things that are algebraic then in chapter two. Now, but all those same things apply. Sometimes there's new rules when you're dealing with something new, like for example with algebra, so we'll see. You know, you got special things when you're dealing with x and y, how you got to add them. You got to make sure you do a certain thing, and when you multiply them, you got to follow certain rules. And then after that, we get chapter 11, which is pretty basically right after Mardi Gras. And chapter 3 is a little bit different animal. It's like the graphing of lines, that type of thing. Also, some inequalities. And then we got chapter 5, which deals with what we call monomials, polynomials, essentially exponent work that we do. And then that brings us up to about midterm. And then we have midterm from everything from that point up. We also got a test on each one of these chapters. I may not have said that too clearly, but see, like there's a test one, chapter one test, then a chapter two test, then a chapter three test, and then a midterm, and then we go to chapter six and have a test, and so forth through 7 and 10 and 11 finally. And that brings us up to the end of the semester. Now, this class meets essentially 5 hours per week, is what it's called, a 5 hour a week class. In other words, we spend about 5 hours, more or less, probably a little bit less, in the classroom, and it's a little bit larger than a regular 3 hour class. That's why the class meets for almost 2 hours on our Tuesday and Thursday days. All right, so that's the other big thing. I'll have this out a lot, and this is one of the most important things because I keep up with this. Because if we don't keep up with this, then it causes problems for us because then, you know, it means we got to introduce something very quickly and not cover it for very long because we got to get all this material in because there's a departmental final exam and you got to be prepared, you know, for that exam, meaning covering everything that's in here. All right. So
I'm
that's
sorry.
the other main document. All right. Now, as I said, is all the work is done through the system called My Math Lab. Now, what you have to do, and this is really about as easy as it's ever been to do since I've been here at Delgado. It used to be that they would make you go and get the code and put it in and all that. But this is what they call first day books. So what you do here is, and this is not a, let's see if I can, oh, this is really weird. Are y'all still hearing me?
Yes.
Yes.
Okay, good.
Yeah.
Yes.
Right. This is just very strange. Anyway, I'll just show you. I can't really show you as a student. Well, I do can get into a student view, but as I've heard, that it doesn't really work too well. But what you want to do almost immediately, and if you can do it now, do it. Click on this course materials item right there. All right. And this kind of bridges the gap between the bookstore in Delgado and the publisher of the textbook. Now, you should only see one of these things in here, and it should be this one right here, because I've got it linked. It says the 097V14. So what you're going to do is you want to click on this launch courseware, and I put this in the announcement I'd send out. Technically, you can opt, they'll ask you on the next page. Like I said, I can't show you that because I don't think mine view shows you, because it's already linked and it'll just into the My Lab. So what you want to do is when you click on launch courseware, there'll be something where you can opt out. Unless you really know what you're doing, don't do that. Use the opt-in thing, the one, because what's going to happen is it's going to automatically line up that textbook for you. And like I said, it's through that first day books thing. You can opt out if you don't want to do it, because you've got the right to do it. But you're on your own as far as getting the material that you need to get for this class. This is set up to be for it to be foolproof for you. You just click on launch courseware, and then I think there's one more thing you got to click. It says something like, see, the thing is, it says something about opt out. So I think on that next page they give you the chance to opt out. But like I said, unless you really know what you're doing, I wouldn't do that, because if you do that and you don't have your materials, then you cannot pass this course without getting those course materials. In the past, one of the things that students would do when we're doing this manually is they would get the 14-day code and then, kind of use that as a trial to see if I'm going to be able to do well in this course. But the truth is, you're not going to be able to tell in just 2 weeks. If you've not, kept up with things in 2 weeks, you're going to have to buy it at some point. But what this does is it ends up buying it for you, and it somehow goes through the Delgado process and paying for it. I guess it charges it to your account or whatever. It's a way to look at it. All right, anybody got any questions?
So with the MyLab books, it also like comes with the MyLab code and stuff?
No, you don't have a code anymore. That's the whole point. You just click and you're in. There's no more codes with this way. You just go click through it, because I've already got it linked. Did you see that right there? Like I said, this is your class right there. So what that means is when you click on launch courseware, it's going to open this up to this point after you do the initial setup. And then from there, you go right in and start doing your work. And because I've already got them linked, then you're going to be in the right course.
Okay.
What you got right here. Like I said, you should not have to go anywhere. You shouldn't have to buy anything. It all handles for you. Handles everything for you. And most everything that you want to look at here is under assignments. So that's where you're going to see things. I don't know why there's not anything showing. Hold on a second. It should be there. Let me just look and see. There's something so strange here. Because they're all set up. Just make sure I'm not missing something. 111. That's already passed, isn't it? Oh, I bet you she's not assigned these. That's good. Okay. So I'm just going to assign them all now. That's what it is. I don't understand why we went through all this trouble and then didn't assign them, but all right. So anyway, this is really the only place you need to go and do any work is in my math lab, because my math lab has everything that we need in it to do every bit of work. All right, so that one's in there. I'll just go back and see what's going on there. Should already be up and operating. I guess I'll just go through and do them all one at a time. I don't know. I'll figure out. Anyway, now you should be able to see that's where your work's going to be at in the assignment center. You'll have homeworks like these right here, which are things where you can go through and learn with initially. You can do them as many times as you want. In actuality, you can get 100 on each one of these before you move on. And then you'll have some quizzes, which usually have like a set number of attempts to help you practice for testing. And then you'll have a test, which will be just kind of a one-time thing. You'll take it one time. All right, any other questions?
Not at the moment.
All right, so let's see how I'm going to do this roster thing, because the system I was using before made it a little bit easier. I'm just going to call your name in the Janacia Bell.
Present.
Okay. Miranda Boudreau. Miranda Boudreau. Rashawn Broomfield, I saw earlier, yeah.
Yes, I'm here.
Courtney Butler. Courtney. Ross, I saw it there. Lanisha Cloud. Casey Cook.
Present.
Is it Casey or Cassie?
It's Casey.
Okay. Shantae Finch. Shantae. Chloe, I saw out there. Christina Foster.
Here.
Zachary, I saw Zach.
Yeah, I'm here.
Yeah, okay. Victoria Gonzalez, I saw.
Here.
Brittany Gordon, I saw out there. Remy Ebos,
I'm here.
is that right?
Yep.
Okay. Taylor,
I'm here.
Bruce Hughes. Landon Ingraham,
Here.
Timothy Malaz. Timothy. All right, I saw Sonny Matthews out there. You still around?
Here.
Brittany Mustasha.
I'm here.
Sophia, I saw out there.
Here.
Andy Nguyen. Andy. Emily Peterson, I saw, I think.
It's Peterman.
Peterman, I'm sorry. Vivian Sullivan. Tyrone Sutherland. Arnisha Taylor. Denasia
Here.
Alexandra.
Here.
Christopher Weber, I think I saw him there, yeah.
Here.
And then Darren. All right, and I'd also put, I don't know if I addressed this in the announcement that's out, but, announcements come through here. I put them in here, and it goes to your default email address, whatever that is set up to be. So if you changed it, I got no way to know what it is, but usually it's the Delgado email address is the default. So anyway, I know I talked to some people that were, like upset about the class going to virtual, but I mean, there's nothing really that we can do about that because all classes now at Delgado are virtual this semester until further notice. Even classes that were originally to be face-to-face, those have been suspended and going online. And I know with these, they're not going to go back, to on, face-to-face anytime, during this semester because they don't want to switch back and forth. But that's it. I mean, but I've been doing this since the spring, and I've had plenty of success with this class. So I may not seem like I'm all that great of a teacher so far, but I'll try to answer any question you have. I'll try to go over things as much as you want within the time constraints that we have. And so, that being said, I want you to feel comfortable because I think that you can be successful, just as successful at this virtual class as you could for a regular face-to-face. All right, so the other thing you want to look at, and this is what we'll go over in class, is there's all these other important things that you might want to read. I'm not going to get into them unless you got questions about them, but basically it's about things that you're supposed to have, which should be kind of self-evident, like writing materials and paper and that type of thing. You can go through it, and then the technology information is, you got to have a computer to get online with, and it looks like most of y'all have that. I mean, if you got only a phone, there might be a problem. Because the reason being is because for the midterm and final, you have to go through this proctoring system. It's called ProctorU Record. And essentially, you just sign up for a ProctorU account. And then what it does is then you go and launch the test in my math lab, and it records you so that we can look at it and make sure you're doing your own work and that type of thing. So you got to have a computer that runs that. If I'm not mistaken, a regular PC will do that, or a laptop, Mac. I'm not 100% sure about like Google Chrome. I love Google Chrome and I use it all the time. And I know there's some things I can't use it for, but this may be one of them that makes me wish that it did. But you don't ever know what's going to happen. They may be able to bridge that gap before. All right. This right here, you don't really even need to see that because that's for something up the other way. All right, there's some things here about study skills you might want to read. Again, it's hard to know in a class like this what everybody needs because some people are coming in that could probably do most of this course already anyway. They just need work on the last stuff. And then there's some people that need, work on everything. And then there are some people who maybe need help with study skills. So that's why something like that's in here. But anyway, the things that I wanted to tell you about is this the material here for each one of the chapters we're going to cover. So what I'm going to do is, if we go in here to this one, chapter, hold on a second, let me look at this. Okay, that's what it is. We're not there yet. I just wanted to see what they had in there. I couldn't remember. All right, so inside of this chapter 1 material, for each section, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, there's both a PowerPoint file. It's actually a PowerPoint file that's been converted to PDF, makes it a little bit easier to transfer and use. And then the other one thing, it's here, it's a worksheet. That's what we'll go over in class. And usually what I'll do is I'll go over selected problems on here, and then I'll, like I said, for chapter 1, there's not a whole lot of stuff. Like, for example, this is really a worksheet, even though they call it that, but let's look at it. All that this 1.2 thing does, it just tries to get you familiar with some things, some terms. We'll just look at this real quick. It's really not even that important in the great scope of things. It's just when you see these terms, you know what they mean. These numbers right here are in that little set right there. They're what we will just call whole numbers that start with 0 and they count all the way up. And that ... just means it keeps going on forever. So it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 on and on and on to infinity. Now, if we didn't have a 0 there, these would be called natural numbers. In other words, if you don't have a 0, it's just called natural numbers. But these are what we call whole numbers here. Now, when you don't have the 0, like I said, it's called natural numbers. You could even say counting numbers as well. These things right here are called inequalities, and they're called inequalities because that's what they are. If we have an equal sign, that's an equal sign. But if we have one of these 3 other symbols, they're called inequalities because they have either not equal to, which is what that first one is. They have less than or equal to, and then there's the greater than. Now, for both this one and that one, you can either have the equal sign underneath it or not. All right. But these are called inequality symbols because in each one of those 3 cases, they're accounting for a span of numbers that's not just equal to one thing, but more than one thing. All right, now when you throw in the negatives to your what you call your whole numbers, those are called integers now. Integers are positive and negative numbers, any whole numbers, positive or negative, including 0. Not okay?
Yeah.
Yeah.
All right.
I have a
Let me know if
question.
you got any questions. Now, they don't have anything in here about rational numbers yet. Rational numbers just means that the numbers that can be written as a fraction, and irrational numbers are numbers that are like square roots that can't be simplified. So they don't really say too much about that at this point because they don't really need to. But the whole set of numbers that most people work with on a regular basis are called real numbers. A real number is just a number that has a spot on the number line. And the real numbers holds all the numbers, all those other ones in all of these categories are subsets of that, of the real numbers. Now, this is what we call a rational number. A rational number is specifically one that can be written as a fraction. It doesn't have to be. For example, 2/3 is a fraction, 3/4 is a fraction, but 2/1, even though it's technically not a fraction, it's a whole number, it can be written, the number 2 can be written as 2/1, so it is still considered a rational number. So this right here is simply saying any number that can be written over another number is called a rational number, fractional. Now, this is just kind of almost self-explanatory because it says non-rational numbers. Well, that's what we call irrational numbers. And that doesn't mean that they're crazy. It just means that they're numbers that we can't write as a fraction. Because if you were going to take the value of, let's see, find a good calculator. See, like if we take a number like square root of 3, that right there is what we call an irrational number. It's got a spot on the number line, but what happened? Oh, put it as scientific notation. But anyway, that 1.7320508075688773, that's just an approximation. That thing will go on and on and on and on and on and on forever, because an irrational number is a number that will never repeat decimal wise. So that's why it can't be written as a fraction. Same thing with something like pi. Let's see if they let us. What's it equal to? Can you hear me all right? This thing's all getting like connected. Okay? I was trying to show you another example here, but I'm getting an error here. It says check my internet connection. You hear me okay?
Your audio is cutting in.
Yeah, it's lagging a little bit.
Yeah, just a few minutes. I don't know if I would have. Anyway, well now it looks like it's back. But anyway, y'all hear me now?
Yeah,
Okay.
much
For
better.
some reason, yeah. But anyway, that number right there is called pi, 3.14, blah, 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 blah. You know, there's people who have spent years like finding out how many decimal places you could approximate pi to. And the reason why we call it an irrational number is because there is no way to take it and write it as a fraction. It's always going to be written as it has to be rounded off to some decimal places. Now, it's not really, this is not something that you really need to make note of, but if you understand what I'm trying to tell you about it, that's what an irrational number is. Like I said, is the important thing is if you see these terms, it might help you to know what they mean. Now, this number 8, it says the distance between a real number b and 0 is called, it's the second one here, it's called the absolute value. Absolute value is distance on the number line, and it's the distance of any number on the number line from 0. So some of you might remember this, but if you have, to take the absolute value of 2 and you take the absolute value of 2, or negative 2, they would both be equal to 2 because they both are 2 from the
Can't hear you again.
Yeah, it's lagging.
See if I can find a nice little. What's the matter?
Repeat what you just said.
It's
We didn't hear you.
lagging.
Oh, hold on a second. I was trying to find something. Oh, the absolute value. I was trying to find something to illustrate the absolute value. All right. And this is a good little illustration for this one here. All right, so am I sounding okay now?
Yeah. For now.
All right. So absolute value, it doesn't matter whether we're talking about negative values or positive values, but what it means is distance. So if we've got sea level at 0 and somebody is on top of a house and it's 60 feet, above sea level, and then there's somebody in a great big hole that's negative 75 feet below sea level, well, which one is furthest from the starting point is 0? Well, the person in the hole is, because that takes 75 hops of 1 to get to it, whereas the 60 only takes 60 from 0, 60 hops. So that's what absolute value is. All right, so here's one of just testing our knowledge here. What one of these signs can we put here and make this a true statement? Is 13 less than 20? Is 13 greater than 20? Or is 13 equal to 20?
Less than.
Yeah, it's less than, and that's the only one that will work right there. You can't put the greater than because 13 is not greater than 20. So 13 is less than, good. Same thing here, 3.97 and 3.97. There's not going to be an inequality that's going to go in there because these two are equal. So the equal would go in there in this case. Now on this number 11, it says 0 and 6. So what one of the symbols can go in there? And there's only going to be one of them that's going to work. Is 0 less than 6? Is 0 greater than 6? Or 0 equal to 6?
Less than.
Yeah, it's less than. Now, here's where you got to watch it because this will take, make your head spin here. Because if we're dealing now with positive numbers and negative numbers, we got to make sure we got them right in our head. Is 5 greater than negative 5? 5 less than negative 5? Or are they equal?
Greater.
So 5 is greater than. And that being the case because of the fact that if you, let's see if we can get a little ruler. Well, see if I can find one that's kind of help us do this. So, yeah, here's one that's got a 5 on it. Oh, yeah. So the negative 5 is here to the left, and the regular 5 is over there to the right. Now, the way that the number line works is anything to the left is always less than anything to the right. In other words, anything over here is greater than everything back this way. So negative 20 is greater than negative 25. Negative 15 is greater than all of these down here. Same thing, all the way up. Everything down here is greater than what's to the right. So when you're dealing with the positive and negative numbers, you kind of just gotta make sure you got a nice number line in your head. That helps a great deal to do that. All right. So how about this right here? It says 1 is less than or equal to 1. Is that a true or a false statement? Is
True.
1 less than or equal to 1? If it
True.
did not have that equal sign underneath that, then it would definitely be false. But when you throw in that equal sign underneath there, that means that anything to that left, as long as it's less than, all the way up to what is equal, would make it a true statement. Because 1 is equal to 1. So the little equal sign underneath there makes this true. That's what the inequality with both there means. It means one or the other. All right, here's another one with a negative sign. Is -9 greater than 0? Like I said, you might look at a number line to help you. -9 would be here.
-9 is less than 0.
Right. Because zeros are there. And anything to the left is always going to be less than. -5, is it greater than -2? This is where we get a little bit complicated.
Less than.
Let's look at it and make sure. So it's -5 and -2. So -5 is right here. All right, we got one little pointer. And -2 would be right about there. So -5 is less than because it's to the left of that -2. Now, the numbers switch around when you're on the left side of 0 as opposed to when you're on the right side of 0. Because 2 is less than 5. Just plain old, positives. But on the left side, negative sign, the negative side, a -2 is greater than a -5. Because the -2 is over here, it's greater than this. So just the opposite. So you got to watch that. All right, so write the following sentence as a mathematical statement. All right, 13 is less than 14. Now there's a way that I can, let's see if I can find this thing. I got this thing that is real neat. Actually, I can also do it on this little board over here. Thing called. All right, I'll still here to. I don't know what's going on. All right, I was trying to see what that board is called. I'm using Google makes a Jamboard, that's it. All right, so for number 16, oh, I got to share my thing. So for this one, it says write the following sentence as a mathematical statement. 13 is less than 14. What happened to my Zambor? I just never did open up. All right. So this is a neat little board. Allows me to write on here to make it more like a regular classroom. All right. Let's see how this thing goes. Boy, I said a small break and I don't remember anything. What is it doing new in here? All right, let's do it inside of this one. The way to create another one, unless I've used up all ones I'm supposed to use. But we're still a lot here. Okay, so y'all still hearing me okay?
Yeah, it's kind of lagging. We can't hear you.
Yeah, I can't hear you either.
It's going in and out.
We couldn't hear you.
Okay, how about now?
Yeah.
Yeah, a little better.
Oh,
He keeps like. No, we can't hear you.
No.
okay, how about now?
Yes.
All right. I haven't had no much trouble with stuff. Let's see. All right, so what they were at.
Can't hear you. Hello. Can anybody hear him?
No, I can't even hear him.
No, I
I
can't
think
hear
it
you.
froze.
Like, frozen.
All right, we ain't like learning nothing today.
Best first day ever.
Right.
What time does this class
This shit lit
end?
as hell.
Like 5:30, I think.
Wait, no, you're kidding.
No, for real.
That was way too long.
4:45, right?
Oh,
Yeah,
maybe. Oh, my bad.
4:30.
It's like 4 something. My bad.
Okay, I'll take that.
Don't do that, please. Don't give me 5:30. Yeah, it's 4:30. Usually 4:30.
Okay, I can do that.
Wait, where did
I'm so confused.
The teacher's not in the class anymore. I don't know what happened.
Everybody started talking when he left.
I go to real school too.
Real talk.
Y'all day been all right?
It's been good.
It's going good.
Hey, bro,
I
I just woke up.
My teacher keep nagging me.
Man, let's take a 5-minute break.
Oh,
said let's
maybe
take a
he's
5-minute break.
he's taking a he's the test student, I guess.
I guess it's bathroom break.
All right, we can make it 10. We can make it 10
That's what I
minutes.
was thinking.
Right?
Y'all said 15?
Right. All right.
30 it is.
30 it is.
Is this y'all's first semester doing Zoom?
This is my first semester ever.
Yeah,
Me
same.
too.
That's my first.
It's
Mine
weird.
too.
This is my second semester.
It's weird with the Zoom. I don't know how I feel about it.
So it just like jumps from here to here.
Oh no.
This game, I think I beat
Hmm.
Hey,
He
bro,
can
we can
hear
still
me.
hear you, though.
Yeah.
Are we all leaving?
It's all good, man.
it. It's cool.
He can still hear you. All right, go back in your room. Go back in the room.
Mama,
You distracted me.
you distracted. You called me in here. Why don't you put your camera on?
I don't want to.
Are you muted?
No.
No, bro, we can hear you, bro. We hear everything right now.
Go away.
All right, I'm going.
Go away.
That was my plan.
Hey.
He back.
Back.
I think so.
Can y'all hear me okay?
Yeah.
Yeah, for now.
Oh,
Yeah. Well, I just restarted everything. I've not had this. You don't usually have this kind of issue. I mean, it's not uncommon because there's so many people using the internet these days. But probably what we'll do with this class is we'll probably take a small break, like halfway. So we can just consider that our break for this time.
Mm-hmm.
But anyway, let's just go back to those things that we were looking at. But you hearing me okay?
Yeah.
All right. All right, so I'm sharing the screen. All right, already, no wonder. It's just taking a while to show it. All right, so as I said, we were dealing with which one was it? Oh, 13 is less than 14. Well, 13 is less than 14. When you got things like that, translating from words to numbers, you got to make sure you get it right. Okay, about the order. Order is important. Oops, is the record still on? Yeah, I guess it's still on. All right. So here's another one. 7 is greater than or equal to 1. So 7 is greater than or equal to. So when we have equal to, then we got to have that little line underneath there. This was just a plain less than, no equal to. This is a greater than with the equal to. You can have an equal to underneath either one of those. All right, so use integers to represent the values in the statement. A mountain has an altitude of 550 feet. A land lies 7 feet below sea level. All right. So the integer blank represents the mountain's altitudes, which is 550. And you can kind of think of it like this. This is your mountain. All right, and here's your land, let's say. They actually have some mountains, like Hawaii, I think, is just a bunch of mountains that actually start on the seabed. So anyway, let's just say that this is sea level right here. So that's 0. So the top here would be 550. And then the land that's under sea level, sort of like New Orleans, would be right here, the -7. So when you have something like that, where you're talking about positive and negative numbers, a good representation is something like that with, what happened to that? You can't see that, can you? That -7. That's your -7 right there. That represents the below sea level. This would be where sea level is at, and then 550 is the top of the mountain. All right, here's another way you can use positive and negative numbers. People don't think about this. And I found that with math, when you get confused, if you like break things down in terms of money, it'll make it a little bit easier to wrap your head around because everybody or most everybody likes money. All right. Brian Eckerd deposited $852 in his savings account. He later withdrew 262. So the 852 means that's his balance. And then he withdraws 262. Now they don't ask us for this, but how much would be left in his account? Let's say it would be, do a little cheating here. But he's got $590 left in there. All right, let's just get these last ones out of the way and then get on something a little bit more interesting. All right, so again, they're asking us to insert the proper term here. Is -80 less than -10, or is it greater than?
Less than.
Yeah, it's less than. If they were both positive, then 80 is certainly greater than 10. You'd rather have $80 rather than $10. But since we're talking about negative numbers, we're talking about things like debt, is the way I like to put it. If you owe $80, that's a lot different than owing $10. All right. You're further in the red with that $80 negative than you are with the $10. So that's a less than. Now, the last thing is that absolute value stuff that we talked about. That essentially means that those absolute value signs, which is just like this straight up and down little line there, that just means that we're going to eat the negative sign that's in there, essentially, and spit it out. So -8, the absolute value of -8, is equal to 8. Now, in this case, they gave us -8 and -8. Now, they could have made one -8 and one just a +8, and both of these things would be the same anyway, but there's only one sign that's going to work in here, and that's the equality sign. They're both equal. Now, on the number 22 just does what I had just mentioned. The absolute value of -4 is equal to 4. And so also is the absolute value of 4 is equal to 4. So in this case as well, these two things are equal. These are equal to one another. Okay. All right, so let's see what else we can get into. All right, so this is where we're just going to look at some of them. I'm going to kind of give you some of these to do, and you tell me what you come up with. All right, so one of the most important things in mathematics, and most people don't like it, I don't like it working with it generally, but it's a necessarily evil because if you have fractional amounts and you want to add them, then there's got to be a procedure for that. Now, if the denominator of the two fractions that you're going to add or subtract is the same, then all we got to simply do is just use that denominator one time in the denominator spot, and then just take the two numerators and do whatever the operation was, which in this case, it was subtraction. So 17 minus 17, 7 is 10, and 10 over 24. Now we can reduce fractions. If we, in this class, generally you're told to reduce them, but just, I still have students like even in 200 math, level math, ask about, are we supposed to reduce these? Well, generally speaking, an answer is not simplified unless it's a reduced fraction. So just kind of remember that you always want to reduce fractions. The only time you may not want to reduce it is in a situation like this where you're going backwards, and I'll explain that in a minute. And there's a point in that. So now they both have a common factor of 2. Another 2 goes into 10 5 times, and 2 goes into 24 12 times. All right. So then that simplifies down to 5/12. Now, add or subtract, the procedure is the same, but if they don't have the same denominator, then we can't add and subtract them, because it's essentially like if you've got apples and you got oranges, then you can't say, well, how many apples do you have or how many oranges? If you're just talking about fruit, you could put them together. So that's what we have to do here. We have to kind of specify a common denominator fruit that this 8 and this 6, which are definitely different, are going to turn into. Now, how does this work? If we got 3 8s plus 5 6, the denominator is not the same. So what we got to do is we got to find the least common denominator. So I'm going to write this over here, and I'm going to put a little bit more work in there than they have, because so it's 3/8 and 5/6. Because if you don't know how to do this, I'm going to show you the procedure. Was it 3/8? Yeah, 3/8. Now, how do you find out what the LCD is? Anybody know the answer to that?
Hello?
Yeah, I don't think I could hear you again.
His sound going out again.
All right. Can you hear me?
Yeah.
No.
All right. So anyway, this is what we got to do. You got to break these down into their basic elements, what we call prime numbers. You don't always have to go this far, but I'm just going to show you what the procedure is. Oops. Bring that one down. So the total factor form of 8 is 2 times 2 times 2. Okay. Can't break it down any further. And now this one's going to be even easier. And like I said, if you can tell that it's 24, all the more power to you. You don't always have to do this. It's just that sometimes I know people want to know why this works. And this is the only thing I know to tell them is just you break it down into the basic elements. Because 2 times 3 is 6. That's a funny looking 3, but that's a 3. All right. Now, in order to find the LCD, what we're going to do is we got to look at the number of each one of the factors. Now, the easy one is 3. It appears one time on that side. Now, here's the part that a lot of people get confused about is we need to have a certain number of 2's there now. How many 2's do we need? Well, we got to have enough 2's to account for the maximum amount that appears in any one of these. There's only one over here. So there's the thing we got to look at is this right here, which is 2 times 2 times 2. Now, another way to write that is 3 times 2 to the 3rd power, or 3 times 8, which is 24, which is what we had said over there, what they had showed us, that the LCD was 24. Well, why was it 24? Well, this is why, because we break it down into its base components, that we take the 1, 3 that appears, you picking it the maximum amount of time it appears in either one of these. Right there's 1, 3, and then you got 3 2's you got to throw in there, which is essentially 8. Now, over here, then what are we going to multiply by here? We got to multiply by the factor that gets each one of these to be 24. Now, you can kind of look at it sort of like this. This is 6, so you just need to have 2 times 2, which is 4. And if you multiply it on the bottom, then what's really important is multiply it on the top. Because whenever you multiply by a number over a number like that as a fraction, you're not changing the value of it. You're just changing the appearance of it. And over here, well, 2 times 2 times 2 was the 8, so we needed a 3, the missing 3. Okay, so now what's important is what's up top. All right. 3 times 3 is 9. And then over here is 5 times 4 is 20. 5 times 4 is 20. All over 3 times 8 or 6 times 4. They're both the same thing. 24. Did I do that right? Look at that. And then 9 plus 20 is 29. And there we got it. That's our final answer. Now, if there's anything in there that can be factored out, in other words, like 3 divides into 24, but not into 29. And then 2 doesn't divide into 29 either. It divides into 24. So that's why that one won't simplify. But if there's any common factor there, you take it out and reduce it. All right, so I want y'all to work on these right here. The first 3, well, the first 2, it's just going to be a matter of adding up the numbers or subtracting the numbers in the top. And then the ones after here are the ones get tried. So try to do these real quick. I'm going to do them and see what I come up with. And y'all can let me know. All right, anybody got a number on that? The first one?
3.
For number 1, what do you come out with?
Yes, 3 4. 3 4.
Yeah, 3/4 on that first one. Okay. And then the second one,
1/6.
1/6.
yeah, it's 1/6. So I can put these there if you want to take a look. And as I said, since I'm recording the session, you can come back and look at these. The top one and the bottom one, I'm sorry, both of those, they could be reduced. So like the top one was, what was it? It was 12 over 16. And then so I sometimes kind of use a hunt and peck kind of way. And that works fine for me most of the time. Is rather than taking out the largest one, if they're both even, I'll just break them in half. And then if it's not, if they're still both even, I'll take out 2 again. So that worked for both of those. All right, what about the next ones? Let's see. We may not have enough time for all of them. Let's see. We'll do 3 and 4. Try 3 and 4. Now, with 3, notice that there's no least common denominator there, so you're going to have to find it. Now, this is a kind of a problem. They didn't really show you one of these in-between types, but it's kind of in between these two as far as difficulty is concerned. And the reason why this one's not quite as tough as example 2 is because one of these, for 3 and 4, one of those fractions contains the LCD already.
Right.
On number 3, the second one, the 5/18, the 18 is your LCD, because the 6 will divide into 18 3 times. So that means the 1/6 is the only one that needs to be multiplied. So this would be 8/18, which is 4/9. All right. The same thing with the fourth one. See if you can figure out which one of those is the LCD. After this row, you're going to have to kind of figure out what the LCD is. It's not going to be either one of the numbers in the denominator. All right, what happened? What answer did you come out with on
What half?
number 3?
Oh.
Does 4/9 make sense?
Yes. 4/9.
Yeah, 4/9. What about number 4?
1/2.
What is it?
1/2.
Yeah, 1/2. Okay. So you can see there that
Excuse me, can I go over like the steps, like how we got 4/9
Yes,
for number
please.
3?
that's what I'm trying to show you here. Hold on a second. Can y'all see my screen over there? I can make it bigger, but I just was trying to see if you could see it.
It's hard to see when you're sharing the.
Yeah.
You can
Because
click
now
on
it's
his
on
picture
screen
and it'll make it
share.
bigger.
Yeah.
It's like,
I'm just trying to figure out how to get the screen share off. Because it's got my video. It's just, but how do you share? I want to share the video. Let's see. I can write on that board, but it's no fun doing it like that. Just writing with a mouse, it's not that. But there's got to be a way to get my camera back. So I'll just try to do it on the board. It's going to be slow, and the problem with this is it's not as fast, so I'm not going to be able to go over every one of them, but we can do it on here. I know there's got to be a way to go back to the camera on this. All right, so if it wasn't for fractions, I could type it out, but all right, so the LCD is what? Is 18.
Yeah.
Because 6 will divide into 18 evenly. How many times will it divide into 18?
3.
3. So we got to multiply this one by here by 3 to give us the 18. We already got the 18 on the right-hand side. So for here, it's 3 times 1 is 3 over 18 plus 5 over 18 which is 8 over 18. And what did I say the answer was?
4 over 9. 9.
What's it going to be?
4/9.
4/9.
Because 2 divides evenly into 8.
Yes, sir.
And 2 divides into 18 9 times. So that's our final simplified answer. Any questions about it?
No, sir.
All right. All right, well, why don't you, let's see, we're not going to be able to do all of these. Let's try to get one subtraction and one. So number 5 and number 7. Try number 5. So the LCD for number 5 would be what?
20.
Because 4 doesn't divide into 5 evenly and neither the other way around. So we got to find another number. Now, oftentimes, you can simply take the 2 denominators and multiply them, and that will give you an LCD. Now, but it won't always be the least common denominator. But in this case, if you take 4 times 5, you get 20, and that's your LCD. All right. Just because of the fact is this, because 5 is a prime number, it's not going to break down any. But the problem being is, like with some of these other ones, as you see, you got to, well, we'll probably take a little bit longer look at 8, just because that's one. You don't want to multiply 24 times 16, because then you're going to have too big of a number, and it'll work, but you're going to have a lot of reducing to do. All right, so 3 over 4, and they're both going to be multiplied by what it takes to get to. So I'm going to multiply the 3/4 by 5. And then I'm going to multiply the 1/5 by 4. And then that gives us 20 in each case. So that means this is 15 over 20. And then this is going to give us 4 over 20. Any questions up to that point? The LCD is really easily found with this one because you can just take 4 times 5 and that'll give it to you. And the reason why that works is because 5 is a prime number. You don't need to break it down any further. All right, does that make sense?
Yes, sir.
Any way we can break that down any further?
No.
Okay, and this one's going to work pretty much the same way. Did I like write down the wrong one? No, there's
You said 7, right?
Yeah, they both got a 3/4 in it. That's what it is.
7.
Yeah, this was 5.
2, 4.
And this was 7. Okay, again. Now, with this one, you can multiply 4 times 6 and you'll get an LCD of 24. But the problem is it doesn't have to, that's not the least common denominator. And it's not that that way won't work. It's just that on the end, when you're going to reduce it, you're going to have to reduce a lot more than need be. So let me just show you how this works again. So the factors of 4 are 2 and 2. And then the factors of 6 are 2 and 3. All right. Now, what is the LCD? Well, as I had said is, if we had just multiplied 4 times 6, we would get 24. And that's a common denominator. It's just not the least common denominator. So what we're going to take is we got to take the largest iteration of anything that repeats, which is 2 times 2. So this is our LCD. And then the 3 got to be thrown in there because it's got to be accounted for. Everyone has got to be accounted for. But the one thing you got to watch out for is if a number or a factor repeats more than once, then you got to throw that one in the mix. We don't have to worry about this 2 because 2 will divide into 4. So we just take the largest multiple of 2 there was, which is 2 times 2. So what is this? So the LCD is 12 now.
Mm-hmm.
And this will make it easier. And like I said, I try to tutor people sometimes and try to help out. And I'll just tell them, well, if you just multiply across like this and then add, that'll work. It's just that you won't always have the least common denominator. So don't, feel bad if you're not able to catch on to doing this. But I need to show people why, because there are some people who want to learn things that are essentially make things quicker. All right. So if you got a master that works, you hold on to it. All right. So what that means is I got to multiply the missing factor. So essentially I got a factors of 4. That's 4. And then this is 3. So we're going to multiply this by what it takes to get to 12, which is 3. And what does it take to turn a 6 into a 12? Well, it takes a multiplying by 2. So 3 times 3 is 9 over 12. And 5 times 2 is 10 over 12. And if you've got the same denominator, then all it is a matter of is just adding or subtracting what's in the numerator. Now, that's what we call an improper fraction. There's nothing we can do to reduce it. You could possibly write it as a mixed number, but generally speaking, in algebra, improper fractions are what you would rather use. So unless you're told to write it as a mixed number, then that's fine like that, as long as there's no common factor between the two, which there isn't between 19 and 12. All right, let's see. Now multiplying and dividing is a whole lot easier than adding and subtracting. All right, so I'm just going to bring that out real quick. And it's because adding and subtracting is just the thing that causes the most difficulty because of that LCD business. So if you're multiplying two fractions, then you simply multiply the numerators and you multiply the denominators and then you reduce them. However, if you can take anything out top to bottom, in other words, 3 goes into 9 3 times, and that's why that 3 is down here. And then 3 goes into itself 1 time. And then when you're dealing with 4, 4 goes into 8 twice and into 4 once. So if you do that before you do multiplication, generally speaking, these things will be a lot easier to handle then. And as a matter of fact, there's almost no multiplication to do. 1 times 1 is 1, and 2 times 3 is 6. Does that make sense?
Yes, it is.
All right. Now, for division, well, division is what we call the inverse operation of multiplication. It undoes, division undoes multiplication. It's like addition and subtraction are inverse operations. And so, so are multiplication and division. One undoes the other. So when we divide, we simply multiply by the reciprocal of the value on the right. In other words, 4/7 divided by 2/3 is 4/7 times reciprocal, which is 3/2. And then once you do that, you go back up here and start all over with the multiplying. In other words, 2 goes into 4 2 times. 2 goes into 2 once. There is no common factor between 3 and 7, so those stay the same. And then it's 2 times 3 is 6, and 7 times 1 is 7. And this should be kind of obvious. Let me just kind of explain something to you. And I think you'll understand this once you see it. People do this all the time and they don't think about it. That if you want half of something, let's say we have $10 and we want half of it. Well, if we divide 10 by 2, we get 5. You can also multiply by 1/2. So 10 times 1/2 still gives us 5. So those are two inverse operations which you use and you don't even think about it. It's just that you have to do it when you're dealing with fractions because it's not so easy to see as a simple, like a 1/2 or even a 1/3 or what. All right, so try every other one of these. Let me, do I still have the calendar out here? Yeah, there it is. So we're all right on time. Does anybody remember what the end of the class time is? It's something like
4:35, I think.
4:35.
Is it 4:35?
Yeah. Yeah, it's 4:35.
Okay. Well, I might let you out a little bit early today. Just and if you got any questions, you can stick around, and I'll help you. With anything too. And you've got these things, access to these too. So don't forget that. It's there. I said it's over here under home. And you go down, it's like one. Well, the first one is, where I got the syllabi and the calendar, and then there's Proctor U stuff. You don't see that one. Some study tips. And this is where you start seeing the worksheets in here. So you click on that. And there they are, okay? So anyway. So let's try to work like every other one of these. Probably all we're gonna need to do today. Like I said, I want to make sure I got everybody on board. And if anybody came in late. All right, Christine. All right, so let's say 7 12 times. So if it's multiplication, then you just go straight across, but it does help. Yeah, that's what this calendar is for, all right? See this? In the My Math Lab. All right, and I highlighted the first few of them. I told you that there was, for some reason, they're not all showing. Usually they're all supposed to turn on at the same time. But I highlighted the first two, made sure that they were there. I don't like where the place, that little bar they put, that little bar they put up there is covers all this up. But it's in the My Math Lab, the homework. Everything's in the My Math Lab, okay? So just remember that. That's why you got to get in there as soon as you can. Stay up on this homework, and then there'll be some quizzes here and there. And then that'll all prepare you for the test at this time, see? But that's what this calendar is for. I don't have to show you what we'll be doing on any given day. If something happens, you can't show up, you got this to help you know. All right. All right. So what happened on number 1? 7/18.
Yeah.
Yeah.
Let's go through it. One of the hardest things to do on this kind of boards is make like a dot for multiplication. I won't do that. And they don't really have a good tool to do it. So that's multiplication. So anyway, what I was saying is, now when you put that one next to it, you can now look at it as the 2 and the 7, they're being multiplied up there. So can it take anything out? 2 can go into 12 6 times and into itself once. So just so you can see what's left after reducing. Oops, that's not 2 thirds, it's 1. And that's what you're actually multiplying. Questions about that? Well, like the Windows shows you a lot more than the Chrome does on this. On Zoom, I notice.
So for number 1,
Yeah, it's pretty good.
you said 2 going to 7 6 times. So you're placing our numerator, the numerator 6.
2 goes into 12 6 times.
In 12.
And it goes into 2 goes into 2 1 time. So that's what you're essentially multiplying. You don't have to rewrite this if you can remember what you're doing. But 7 times 1 is 7, 6 times 3 is 18. All right, let's do the number 3. Now this is where you got to keep in mind. When you got a whole number, I had said this before, that a whole number is essentially over 1 to write it as a fraction. Okay, and then that lines up everything for you like that. So the only thing we can do about simplifying is 3 goes into there 12 4 times and into itself once. Okay, and then 1 times 11 is 11 and 4 times 1 is 4. All right, makes sense. All right, let's see. Let's say 5. And that's divided by. So you got to watch out. Because you can't just start off and treat it like multiplication yet. The only way that this up here works, where you can take the things out top to bottom, is if you're multiplying. Times what?
6 over 5.
Mm-hmm. And now we'll just check and see if anything will come out. So 5 doesn't go into 11, but 6 goes into 12 twice and into itself once. So that's 11 times 1, another 11. And 2 times 5 is 10. Okay. Let's see. Let's try number 7. So be the last one here. because like I said, I want to give you a little bit of time. So if you weren't here when I did the roster, make sure you stick around if you, because I need to get you in there. All right. So 8 over 17 divided by 24 over 34. So this right here, the 20 over 34 has got to be flipped. So we can't do anything with it like this. We got to take it and do the reciprocal here. And what that does too is, just because these problems are kind of created for certain purposes to give you these lessons. See now, before, well, the only thing you could have simplified here was with a 2. But over here, once you get it over here in the proper order with the inverted number, then 17 goes into 34 twice and into itself once. And again, most of the time on these multiplication and division ones, once you simplify them, there's not a whole lot of mathematics to do. It's just 8 times 2, it's 16. And then 1 times 24 is 24. Oops, you know what?
No.
I didn't simplify here.
You're
So
missing
I
out.
can either do it here or I can do it over here. It doesn't matter. But let's see what we can do. 8 can go into 16 twice.
Yeah.
And it can go into here 3 times. And you can find the same thing out because 1 over 1 times 2/3, well, it's just 2/3. But this is 2/3 in unsimplified form. All right, so any questions?
No.
All right, well, y'all did good today, and hopefully I'll get the hang of this a little bit better working with this. Like I said, is when they just kind of threw us out to the wolves at the middle of last spring, I just used the thing that was inside a canvas, and it worked pretty good, and I got used to it. And like I said, one of the things I liked about it, and I'm pretty sure I could do it with this too, is I run 2 computers. So that way, if something happens to one of them, you'll still see me on the other one. But I got to figure out how that's going to work, because I don't want to stop doing that. I think that's a good thing to have a redundant system. But anyway, so if you got marked here, let me know. I mean, if you weren't here when I did the roster, let me know now. Or if you got any other questions, stick around. Like I said, we still got a few minutes of class time.
I wasn't here when you did the roll.
All right. So who was that?
Ernesta Taylor.
All right. What's your last name? I'm sorry.
Taylor.
Anisha Taylor?
Right. Yes.
All right. Because I'm on call roll probably about 5 or 10 minutes in every time. I mean, this doesn't ever mess with your grade or anything, but I got to take it for Delgado wants records of it because they want us to turn it in with grades. All right. Who else? Anybody else?
Courtney Butler.
All right. Or if you got any other questions, let me know. Did I get everybody else? I never did see Miranda Boudreau, Lanisha Cloud, Shantae Finch, Bruce Hughes, Timothy Malaz, Andy Nguyen, Avion Sullivan, or Tyrone Sutherland. All right. Anybody got any questions? Like I said, is get in there and get them. Make sure you got your My Math Lab working. And if I was you, I would recommend jumping on the homeworks for the ones that we just looked at today while they're fresh in your head. And then if there's any that you can't figure out, bring back tomorrow. All right. I don't mind revisiting a problem or two to help you. Okay. Not tomorrow. I'm sorry. Thursday. I'm used to this class meeting 4 times a week, but I think this is going to be neat. This one. So we'll see you on Thursday.
Excuse me, Mr. Cruz. You say you do tutoring sometimes?
Well, I mean, I'm your teacher, so I'm here to answer your questions. But when you say tutoring, I have done tutoring for people, but I can't ethically tutor my own students, but I'll just help you as much as I can. If you actually want tutoring, you know that Delgado has a tutoring center. So you can use that as well. They even have, I think they're probably closed down. They probably went back to virtual, but if you got any questions for me, bring them. I got office hours. I'll be glad to help you with anything. Okay.
Okay.
But, I mean, if you actually want somebody, a tutor, there's a Delgado tutoring. And then if you want like a private tutor, that was what I was talking about. I have done private tutoring in the past, but I mean, can't do that with my students as far as paying or anything like that. So my services are here for you during the times I'm here. Okay.
Okay.
The my lab math or whatever, that's under
Course materials.
course materials. Okay, just making sure. And
Yeah,
then
and that's where you always go in. The first time you have to go in and, make sure you don't opt out. Like I said, unless you really want to, but then you got to get your access on your own. I don't recommend doing that, but they did this to make it easier. So you go through that. And then the first time you do it, then after you get signed up, because you got to have an account. So you have to do an account if you don't already have one. And then once you do that, then you'll always go, you can just go in through course settings, and then you'll see.
okay, what is Pearson used for?
Well, it's a Pearson textbook. So that's who's hosting the My Math Lab thing. That's a Pearson product.
Okay.
And it's tied to this textbook that we use. And like I said, you click on the launch courseware, and after you do it, do the initial sign up, then what you do is you do this, and then you click on here, and then that takes you into where to do the homework.
Okay.
And as I said, is if you go to assignments, see, they're all in there now. I fixed them. That's all the stuff.
That's what we did today, right?
Well, we did 1.2 and 1.3 more or less.
And if we go into that, we can see all the work that we did today, like go over it if we need to.
Well, okay, this is where you go in to do your homework. So technically you're getting, credit for doing this. Whereas when we go through over things in class, there's no real way it's really difficult for me to assign credit like that. So this is right here is you go through, like I said, is you got 20 questions here. You click on the first one and you'll see one sort of like what we looked at, fill in the blank. Then these are whole numbers. Then you go on to the next one. Oh,
Okay.
then you go on to the next one. And then you can keep going through until you get them all done. And even if you got one wrong, you can come back and redo it. And you can essentially have 100 for all of your homeworks. And that helps build your confidence. But these right here, like 1.2, is like that sheet we went through that had all those kind of questions on it about the symbols and all that. And that's what 1.2 is. And then 1.3 is where we what we were looking at today. I mean, what we ended with today. So that, and like I said, as you go through and you'll do each of these, and like I said, and you can max it out and get 200. I mean, you can get 100% on these. Because it give you like 3 chances on a problem, and then when you come back, like if you have an 87, you can come back into it and do the ones that you missed again. Whereas like a quiz, when you do those, you got to take it kind of all in one swoop, and then it's going to grade you on how many you got right or wrong. These right here are meant to be done as many times as you want in order to get them right.
Okay. Okay.
All right. Well, I'll see you on Thursday. Post me an email if you need anything.
All right. Thank you.
Mm-hmm.
All right.